Hello students. So today in this online class, this is competitive class, already P01, P02 we have started, and along with that already the question papers has been sent to you people in a PDF format, and later on the solutions for all those questions P01, P02 is being discussed. Hope you have understood that clearly. On your own you work out, and however we will be solving that one on online class. You can utilize that. Okay, so maintain a separate note so that physics separate, maths, chemistry, biology separate means you will be getting so much of questions, new questions along with the solutions. That is why. So today's topic I'm going to discuss is, that is P03, okay, paper 3 physics, that is laws of motion and work energy and power. Laws of motion and work energy concept I have merged together because they are almost similar kind of concepts. So already the question paper, the PDF format is being sent to you people. Around 30 questions are there. It's almost like higher order kind of questions, okay, regarding this laws of motion concept as well as work energy. I have included new kind of questions. So today let us discuss about that. Fine. So let us begin then. So what you do is, soon after you get the question paper along with that means the PDF format, okay, the question paper, what you do, write down the questions by looking at the, either in computer you use, either in cell phone you can use. Write down that questions, leave some space and try to solve. If you have doubt, leave it, leave some space there and just continue like that. So all 30 questions will be there. When we solve here, you can write down the answers there, so clearly you can understand. So many questions will be there, topic by topic you will be getting. That is why. So hope you people are doing well. Okay, fine then. So let us begin. So I am going for the question number 1, P03 physics, work, laws of motion as well as work energy and power concept is merged. First one. See, the set of questions what I have put this time is almost like free body diagram concepts, because recent years you might have seen in all different kind of competitive examination, free body diagram concept is being much repeated one. That is why let us go for the slightly basic, then we'll go for the complicated kind of questions. Okay, let us begin with that. First one, two bodies of mass 3 kg and 4 kg are suspended at the ends of massless string passing over a frictionless pulley. The acceleration of the system is asked. So question number 1. They didn't give any diagram here. They just mentioned a question. You have to assume, you have to check, okay, assume and do the diagram. So frictionless pulley it is mentioned. So I will take like this. A frictionless pulley is there. Two bodies 3 kg and 4 kg is given. So 3 kg and 4 kg are suspended at the ends of massless string passing over a frictionless pulley. So I will take like this. First one, I will take M1. Okay. Why? Because they may ask, they have given how much 3 kg as well as 4 kg, but the concept what we study, along with the formulas and all, it will be very, later on while substituting we can put the numerical values. So M1, that means this is the block, here M2, and here they have mentioned 3 kg and 4 kg are suspended. See, that means one of the mass is higher here, that is why to that. So what I do is, I will mention here, what is that? M1 is equal to, how much is that? I will go for yes 3 kg and M2, how much is that? 4 kg. So which one is actually having higher mass here? M2 is actually having higher mass. So which one will, frictionless pulley, so which side it will start rotating? This side, correct? This will go slightly. So this is M2 into G force. This is M1 into G. Acceleration, this whole system will go like this, right? That is why acceleration will be like this. And this acceleration will be in the downward direction. And what about tension developed here? Of course, it's a string. That is why tension will be there. It's a single string. That is why tension will be like this. So you might be remembering in our competitive class already we discussed too many examples. Okay, different cases we have discussed about free body diagrams. Let me just apply over here. What is that? First I'll go for the set. What is that? First one, first mass. What is the first mass? That is m1 here. So when I apply, okay, law of conservation of, okay, that means energy or something like that, you can understand force always exists in pair. You know that, correct? A force always exists in pair according to Newton's third law. So let us observe, okay, in this particular concept, what are the different forces acting at this particular point when this particular, because we know normally F is equal to m into A, but here whether only one force is acting on body m1, no. Here downward force, gravitational force is actually acting, tension also acting, but it is moving in which direction? Upward direction. So upward direction, that means which force is maximum here? Whether tension direction is maximum or the downward gravitational force is maximum, because this body is moving upward. So which one will be having higher magnitude, which currently on this particular, this one is T. What is the opposite force here? M1 into G is equal to body, F is equal to m into A, right? F is equal to m into A. So what is that? M into A, that is m1 into A, equation number 1. Okay. In detail I am explaining. Suppose anybody have forgot about the free body diagram, you can make utilize. Okay. Next, second case. Here this m2 mass going downward. What is the force which is acting downward? M2 into G downward. Acceleration is also in downward directions. T is in upward direction, but it is moving in downward direction. That means which one will have more effect here? M2 into G having more effect. So this is M2 into G minus T equal to M2 into A, equation number 2. I just read the question and I have just made a diagram like this. So they are asking two bodies suspended in the massless string passing over a frictionless pulley. The acceleration of the body they are asking. We require what is the acceleration. Whether the answers are in the equation form? No, they are all in the numerical form. So we can substitute that one, okay. Because G value they have mentioned 9.8. Let us equate these two. After equating these two, what we get? M2G minus M1. That means I am going to add these two. That is why, okay. And A into M1 plus M2. So acceleration equal to how much, you know? M2 minus M1 into G divided by M1 plus M2. So I got the equation. See, in detail I am discussing. Directly we can substitute, okay. That means suppose you solve such kind of questions regularly, means you will be having the whole. Directly you can use this formula and directly you can substitute. But suppose you find difficulty in understanding how to get this particular formula, remember this. You are just using the concept of force, net force acting on a body by evaluating this. And now what I do, look at there, only 9.8 value is given, nothing else is given. So next, M2 value we know, that is A is equal to M2 how much? 4 minus M1 is how much? M1 is 3. G is how much? 9.8 divided by M1 plus M2 how much? 4 plus 3, that is 7. So 9.8 divided by 7 you will get. So answer is 1.4 is the answer. That means answer is 1.4 meter per second square is the answer. This question slightly looks lengthier, but have a look clearly in detail in a neat way I have done. So if you have any doubt in framing the equation, you can go through these equations you have evaluated, or directly you can make utilization of this equation. Suppose you know such kind of questions, directly you can apply this formula, means you know. Yes, you can find out like this. So next, let us go for the question number 2. Hope question number 1 is clear for you people. Question number 2. It is given two masses M1 and M2 are connected by a light string passing over a smooth pulley. When set free, M1 moves downward by 2 meter in 2 seconds. Ratio of M1 by M2 is. So what they have mentioned, two masses M1 M2 are connected by a light string passing over a smooth pulley. What is the set of? When set free, that means if you leave them, M1 moves downward by 2 meter in 2 seconds. So diagram I will do, almost similar kind of, but slightly some different methodology it is there here. I will take this one as M1 because it is moving downward, right? It is having higher, what I can say, magnitude in its mass, that's why. So I will take M2 here. This will go downward, right? So this is M1 into G. This is what? M2 into G. If you take this set also, there is nothing to worry. Next, it is going downward like this. And look at there. What happens there is, M1 moves downward by 2 meter in 2 seconds. It goes a distance equal to how much you know? 2 meter. Okay? 2 meter. It will go in time how much? T equal to 2 seconds. So tensions developed in the string, of course you know, that is T like this. So this is how we can frame the, what is that? Equation. So now what I do is, I will just apply the previous concept. That means just applying the formulas like this, okay? So here also I will apply. So which one is going down? That means here acceleration is which direction? Upward direction. Here acceleration downward direction, because M1 is moving by 2 meters downward, because it is actually having the higher magnitude when the pulley is set free. So first case I will go for. Here net force acting on this body, tension as well as downward gravitational force. Which one is actually having higher magnitude? By looking at this condition, it goes up. That is why towards direction T. That means tension T minus M2 into G equal to M2 into A, correct? Next, what about this one? M1 into G is there, which is directed downward. So similarly, I can go for that one. So M1 into G minus, so what is there here? T, that means tension equal to M1 into A. Equation number 1, equation number 2. This is what I get. Next, I will evaluate like previous question. What I can get from this is M1 minus M2 into G is equal to M2 plus M1 into A. So what is the acceleration we get here? A is equal to M1 minus M2 into G divided by M1 plus M2L, right? One and the same, right? Hope you can understand this. Have a clear look regarding that equation. So next, what I do is, what they have mentioned in the question, they have mentioned two mass M1 and M2 are connected by a light string, correct, passing over a pulley. So now what I do, I will just make sure, because they have given 2 meter, that means how much distance it has traveled? 2 meter in time. So I will judge, because it is just left free, that means from rest it is left, it started to move downward. So now what I do is, I will use one of the equation of motion, because vertically downward direction, that's why I will use just basic formula. S is equal to half AT square, okay. Yes, we know how much is that? Distance 2, half into A we don't know, we are supposed to find out, that's why. Time also mentioned, time is 2 square, correct? Yes. So I will continue here. So this becomes A is equal to 1 meter per second square. Hope it is clear for you people. So acceleration what you get is 1 meter per second square. So now what I can do here, what I can do is, I will just apply that acceleration value in this equation. Which equation? I can take this one as star, okay. Because in the options you can see there, what is the options they have given? Ratio of M1 by M2, that is why. So I will apply here. So next this becomes what? I'll just make a m1 minus m2 into g divided by m1 plus m2 equal to a. Correct? But a is equal to how much? 1. So I will just write down like this here itself. Next, what about the value of g? Value of g, whether they have mentioned in the question, they didn't mention. But suppose we keep g as it is, means our options also should have contained like that, no? That means along with g and all, but it is actually in the numerical. That means they are getting cancelled. So now what I do is, I'll just write that. So g means 10 I will take, okay? So 10 m1 minus 10 m2 equal to m1 plus m2, equating 9 m1 equal to 11 m2. So m1 by m2 equal to 11 by 9. Let us check the answers. 11 by 9 it is there, and the option is option B. Hope this is clear for you people. So first question, second questions are almost similar kind, and you should be very careful, because suppose you are having time, means it is fine. You can take, you can frame the equations and slowly you can, that means whenever you want to solve this in a fast way, there should be some practice regarding such kind of questions. That means directly you can skip that steps, directly you can use. So these are small tricks, okay. That means you can see there, compare the equations. This will be same for all such kind of, what is that? That means only in case of 2, you can remember this kind of formulas, okay. That means you can make it fast or solve fast. So let me go for the question number 3. Question number 3 has got the 3 set of, that means 3 diagrams are there, free body diagrams. And what you are supposed to do there is, in 3 cases, how the accelerations of the pulleys which are moving are related. That is what you have to see. Okay. Let me read the questions first. In the figure, block ABC. Okay. Each of mass m, that means all are having same masses. Each of mass m have the accelerations A1, A2, A3 respectively. F1, F2 are external forces of magnitude 2 mg and mg respectively. Only that much they have given. But when you see the options, you can understand. That means what? We have to relate the accelerations in these 3 cases. That means you have to find out first what is the acceleration here. So when you get the value for acceleration, compare the 3 cases. So you can see which one, A1 is equal to A2, or whether A1 is greater than A2, or A2 is lesser than A2, or A1, whatever. So let us see that. First one I will go for question number 3, and that is, it's mentioned like this. First diagram in the third question, it is given, this is M, and force which is exerted on that one they have given, F1. F1 means how much is that? It is 2 mg, correct. Now what I do is, I will apply our normal equations here. That means it is going like this, in this direction. So tension, this is mg. So tension, how much is that? T minus mg equal to ma, correct? So m into a. But they have given this accelerations. If I just keep a as it is, means in all 3 cases I will take only a. But they have given a1, a2, a3 are different case acceleration. That is why first case I will take a1. Next, what is given there? Next, the force is applied, right? In which direction? Downward direction. Here there is no block, but force is there. Something is pulling down. So which one is going down, right? With the acceleration a1 like this. So that is why. Which one is greater? This one is greater. The force applied. So it is 2 mg minus t equal to, how much is the force here? instead of force, what I am writing here, understanding, right? So in that equation, when we apply for the first diagram, we get 2 mg minus T equal to, you can see here there is no mass is attached here, just a force is there which is pulling it downward. So mass we know it is nil, that means 0, but acceleration is there, of course, A1 acceleration is moving, so 0 mass, so that means nothing is there, only force is applied this downward direction. It is not due to any physical quantity which is there, in the sense like in physical way it is there, just force is there in this direction which we mentioned already here, correct? So this is 0. So equation number like this you can take. When you evaluate these two equations, what you get is mg equal to ma1, so a1 equal to g. So in first case, a1, in the sense acceleration will be equivalent to what? Yeah, g. I'll go for the second case here. What is the second case? Diagram you can see there, like this. It is mentioned here, mass they have mentioned. How much is the mass? M. And here mass they have mentioned 2m. Okay. In second case, 2m mass is there, which is in the right hand side. That means, of course, it has to go downward like this. This is acceleration, this is tension, upward direction, acceleration like this, and downward forces. Here when you apply, here in this case, that means second case, T minus mg equal to m into, what is that? A2. Here 2mg minus T equal to m, which one? 2m A2, correct? So next what I do, I will just substitute this. So once I start substituting this, what I get is, so 2m here, mg is equal to 2, here 3m A2 we get. So mm, if you cancel, means A2 equal to g by 3 you get. In which case, acceleration in the second case. I think you are getting this. Next, third case is there, one more diagram is there. You can see mass m, here this side mass is there m, and it is actually pulled by a force F equal to just mg, okay, F2 equal to it is. Fine. Now let us just apply that, okay, equation. So here up, tension, okay, so this is T minus mg, because tension is in the upward direction. So next, T minus mg equal to m into A3, because acceleration in the third case I am taking, that is why A3. Next case here, so you can see what type of force is there in the third case. In the third case, already mg we know, again force also there, that means that pulley is being pulled like this. It is not just going because of its mass, right? So already pulley has got its own mass m, correct? That means total force downward is mg. Again it is being pulled down by force F2, that mg plus mg, that is 2mg minus tension. I think it is clear for you people. Okay, next. And what is the acceleration of that? m A3. Now you evaluate this. Once you evaluate this, what you are going to get is, so here mg, so this one, so what you get? Acceleration equal to g by 2 you will get. So in first case, acceleration a1 equal to g, here a2 equal to g by 3 and a3 equal to g by 2. So which is a suitable answer here? Which one is having greater value? A1 is greater than, I will write down here, A1 is greater than what? Whether it is this one? No, this one, correct. A3 greater than A2. So suitable answer is which one? The suitable answer is, yes, option B. It takes time because in detail I am explaining, that is why. So when you practice this in a fast way, you can finish it. Next. Next, let us continue. Question number 4. 3 is over. Next, let us go for question number 4. Question number 4 says, 3 blocks A, B, C, each of mass 2 kg are hanging over a fixed pulley as shown. The tension in the string connecting B and C, they are asking. So, diagram is like this. Okay. In this way. What about masses? A, B, C of each 2 kgs. Okay, this is A, this is B, this is C. And if this is T, means tension developed because of these two. Whether the same tension will be there because it is a separate tension. That means separate string. That is why I will take T dash. So this is a diagram now. So what we are supposed to find out? We are supposed to find out what? The tension in the string between B and C we are supposed to find out. So first what I do is, I will just go for the basic, that is by framing the equations. So what is the equation? In this case, I will just write down here. So here in this case, so T minus mg equal to m into A. In this case, how many masses are there? Just I am going for this T, okay, that is why. It looks like what? B is attached to C. So it is like what? 2 mg minus T equal to, what is that? Minus T equal to, look at there. So mass is there, right? So here mass is present. So as the mass we are having here, I am just using this. So it is total mass 2 ma. Okay. So next, what I can write? That is, when you equate this, this is mg equal to 3 ma and A equal to g by 3 I will get, correct? Like this I will get soon after evaluating that. Next what I do? I will substitute what is the tension between B and C. So let us see B and C because they are going downward, correct? So both are going downward, so tension will be upward, right? That is why. So I will just apply in this C case. Due to see this, okay, T dash minus m into G equal to m into A for C, okay, correct? For C, T dash minus mg equal to m into A because C is going downward, right? So what is the value of m? Value whether we know? Yes, we know. So next, what we can understand from this? So T dash minus mg, whether it is going upward or downward, it is going downward. So it is not T dash, it is, okay, let us make a change here. It's because it is for C, that is why. So this will be going downward. So which one having higher magnitude here? mg will be having higher magnitude, correct? So equal to ma. Just make a change there because it is going downward, because acceleration is downward. Yes. So mg minus T dash equal to m into A is there, and A means you know already. So mg minus T dash equal to m into G by 3 it is. So I will take T dash equal to what? T dash equal to mg minus mg by 3. So T dash equal to 3 mg minus mg divided by 3. So T dash equal to 2 mg by 3. So T dash equal to 2 mg by 3 I will get. But whether our answer is in that form? No. You just apply that in the given data. So what is the given data there? So T dash equal to, I will write here 2 into mass, how much? Each of mass 2 kg into G is how much? Whether they have given G there. G value they didn't mention, but what I will take a standard value for calculation point of view, it is 10 divided by 3. So how much is that? So it will be somewhere around 13.3 Newton. So this will be the answer. Okay, fine. So that is all about which question? Question number 4. So next, question number 4 is over. Next, let us go for question number 5. Question number 5 is slightly different type of free body diagram question. 2 blocks are connected by a string as shown in the diagram. The upper block is hung by another string. A force F applied on the upper string produced an acceleration of 2 meter per second square in the upward direction in the both the blocks. If T and T dash be the tension in the 2 parts of the string, then it is given. So let us draw the diagram. Diagram is like this. 2 blocks. Okay. This is 5 kg and upper one is 2 kg. Next, force F in this direction. Correct. Here tension they have given T. Here tension T dash it is taken. Okay. 2 blocks are connected by a string as shown in the diagram. The upper block is hung by another string. Force F applied on the upper string produces acceleration of 2 meter per second in the upward direction. Both are moving upward in what acceleration? That is 2 meter per second square. Correct? Next what we do is, I will just go for the simple substitutions here. What is the simple substitutions? What we can understand from this is, so I will take cases like this. Okay, that means here force is there directly, so that is why here downward force is acting. Okay, for this one, what is the downward force which is acting? Total downward force, correct? Because it is attached to this one also, so it feels more heavy. For this one, any other thing is attached? No. So only 5. So here 5 mg. For this, total 7 mg. So what is the force applied? Let us see. So force applied is equal to, let us substitute that one there. Okay. So force is nothing but going upward, the direction of tension. Tension itself force, correct? So force minus total 7 mg equal to m into a. That means 7 into 2. Next, for this one, going upward, correct? So as it is going upward, directly what we can write, that is, we can substitute, or I will just try to find out the F value here. Okay, because everything is mentioned. So mass we know there, correct? So mg it is mentioned. So sorry, not mg, 7g it is, because mass itself it is given. Yeah. So this is 7g. So 7 into, yes, of course you know, that is F minus 70. This is 5g, okay, not mg, because kg, right? Yeah. F minus 70 is equal to 14. So F is equal to, so it is 84 Newton. So that means it is nothing but equal to T. First case. So what about the second one now? Second one is how much? 5 kg. So F minus 5g equal to 5 into 2. Because the force itself which is going upward is in the direction of each one, tension. That's why T dash itself is 1. Okay. So F minus 50 equal to 10. So f equal to 60 equal to t dash. Hope it is clear for you people. Make a small change here, that I have written 7 mg there, because not mg, because already 2 kg 5 kg given, so directly m into g, that means 7g 5g I have written here. So correct option, that is C. So that is the answer. So that is all about the question number 5. So while writing the equations, if you write the proper equations, then easily you can evaluate that. Okay. So till now what we have discussed, that is free body diagram under gravity, right? The force acted upon by gravity. Now what we do, we will be understanding about the free body diagram, which is like horizontal force which is acting on that. So regarding this, one question is there. It is question number 6. So question number 6 says, so this question number 6 is, 4 identical blocks each of mass m are linked by thread as shown. If the system moves with the constant acceleration under the influence of force F, the tension T2 is. So let me draw the diagram first. So diagram is like this. This is M. Again, identical blocks these are. M, I'll just draw one horizontal. M. How many are there? 4. Perfect. Like this. So force which is applied is F. Here the tension developed, this is T1. Here the tension developed is T2. Here the tension developed is T3. Now, first what we are supposed to find out is tension T2. To find out tension T2, first I will write what is the net force acting, F, equal to what? F equal to m into A. What is the total mass here? 4 ma. That means A is equal to F by 4m. Just for reference I have written. Okay. Let us continue the question. 4 identical blocks each of mass m are linked by threads. Okay. So individual tension it is been already produced there. So next what I do, I have to substitute only for which one? T2. So I just want T2, so that I will just make use of or use the help of which one? Tension like T1 and T3. Okay. So what is T3 here? So if the second block is moving means, I can just use the equations. What are the equations? Like previous, okay, you can see here also, regarding force we have written. So similarly there also I am going to write. Okay. Tension T2 we are supposed to find out. That is why what I write is T2 minus T3 equal to MA. Okay, T2 minus T3 equal to M into A. But what is T3? T3 is here. Is there any opposite counter force is there? No. So T3, yes, of course it is there. Frictional force is there, but in this question it is not mentioned. T3 equal to what? M into A, correct? So T2 equal to M into A, T2 minus M into A equal to M into A. So T2 equal to what? 2M into A, correct? So T2 equal to what? 2 into, what is that? M into, what is that? What is A? Look at here. F divided by 4M. So answer is yes, F by 2. So got the answer, that is F by 2 we get. So which is the option there? Option is B. Sixth question, option is B. So the answer is F by 2. Okay. So have a careful look here regarding the question number which one? Question number 6. So we have solved that. Next, let us go for the next question. What is the next question? Let me read it. So here, almost similar, horizontal, but vertical force. This one and that one, together it is mixed. Pulley problem and such kind of horizontal one. Okay. Question number 7. Given that a block of mass m1 rests on horizontal table. Okay. Block of mass m rests on horizontal table. Next, a string tied to the block passed on a frictionless pulley fixed at end of the table and other end of the string is hung another block of mass m2. The acceleration of the system is. So the string tied to the block passed on a frictionless pulley, it is mentioned. So frictionless pulley I will take. So like this. Here the mass, how much is that? It is mentioned. Mass m2. Okay. The acceleration of the system is. So if the system has to be accelerated means it has to move down, right? So tension in this way, tension in this way. So here m2 into g, force downward. And here it is pulled by the tension. So now question number 7, yeah. So next what we do is we will just apply the equations here. So what are the equations that I can apply here? That is, first m1, in which direction it is moving? That direction it is moving. So tension is equal to m1 into a, correct? Because what's happening there is we are just applying tension equal to what? M into a, because there is no counter force, it is there, that is why. So in that case, next, what is there here? Next, what we can write is, in next case, m2g. It is going downward, so m2g minus t equal to m2 into a. If you evaluate these two, what you get is, m2 into g is equal to m1 plus m2 into a. Correct? Next, what you can do from this? What they are asking? Acceleration of the system. So I will write acceleration. A is equal to, as we don't have any numerical value here, I will just write what? What is acceleration as it is? What is that? That is what is given there. That is acceleration. Yeah. So that is m2 into g divided by m1 plus m2. So check the options there. We can understand that this option A is the correct answer. Okay. Fine then.